Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 25 of our 30 LeetCode challenge, and the problem that has been given to us today is a jump game problem. Again, if you want to try solving this problem on your own, you can pause this video and check out the link given in the description below. And let's just jump right in. So we've been given an array of non-negative integers where you're initially positioned at the first index of the array. Each element in the array represents your maximum jump length at the position, and you need to determine if you are able to reach the last index. I think you can sort of think about this as a visual problem, and there is a visual problem like this where you think about a frog and a frog hopping across, and it needs to reach the end. One way you can sort of visualize this is basically say that if this is the place that I'm starting on, I can skip over to two elements. Well, my jump can only exceed till 2. If I try to jump over here, I cannot. So I can jump on the first, or let's just call it the index 1 and index 2. So I can jump over there, but I can't jump on index 3. So when we jump on index 1, which is 3 over here, I can actually make a leap and go directly to the last element. And that's what we want to do. So you jump over here and then you get the last element, which is at 3. You've been given another example over here where you have 3, 2, 1, 0, and 4. So your starting point is this guy over here, which I've highlighted, and you can skip over, but if you skip over, you go to 0, and then you cannot really move forward from there, so you're stuck. So you'll never be able to reach the last node. So if I remember correctly, I believe this was a dynamic programming problem, but for me at least, I sort of see this as a very simple problem, and we can use a very simple logic to solve this as well. So logic that we're going to be using is we're going to maintain a variable which can identify like whether we have reached our maximum value, which in other ways you can say that if this is my 2, then I should maintain an index which can sort of help me determine that I'm not yet allowed to go to 1 um, unless I go to 3 and then and 4 and so on and so forth basically. So let's use that paradigm and sort of use that to build out our logic. So we're going to start with a base condition which is just going to be, hey, if nothing has been given to us, then we return a false, I guess. If this throws an error, let's just turn it to a true, but that's okay. And the next thing that we're going to maintain is we're going to maintain a variable called as reach. And that reach variables will sort of help us understand whether we can exceed the range or not. So think of this guy as the reach that we have presently. And what we're going to do is we're going to iterate through all the elements inside our nums list. And I'm also passing in the index because the index is actually really important because it sort of helps me understand that index plus whatever number that I have would basically be, in essence, would basically be the reach. Whatever's the maximum would be the reach. Or in other ways, what I can just say is that reach is equal to max of reach or I plus num. So if you look at the example which have been given to us previously, if you look at this guy over here, you're at index 0. Um, the, the jump that you can make is, well, of the value 2. So you can only go till the second element or till index 2, you know. So your reach sort of gets updated, and when you sort of move across, then you can sort of make all the other iterations as well. So to invalidate cases where you're actually using reach, if your I element is actually greater than your reach, then you have essentially gone to a place where you could not really go. And you can just say, hey, if I is greater than reach, then you just want to return a false. And otherwise, if you don't really hit this thing, then you can return a true. I think a return of true would make sense as you'd never had a condition where you had this, and you're iterating through all the values. So you'll essentially hit the last node unless you hit this guy. So let's do a quick dry run on this. So you have 2, 3, 1, 1, and 4. So let's just copy this and let's just paste this inside so that we can do our dry run a little bit more properly. So we have this guy. Um, and I'm just gonna place in this to denote that this is our guy, and let's take our reach. So our reach is at the very beginning at 0. We don't have reach. When we pass in the first element, at that time our index is 0, which is not greater than our reach, which is also 0. So we can't really move forward with that. And ideally what you're doing is you're checking whether you can make a hop. So now our reach becomes 2, because 2 plus 0 is 2. And then you move on to the next person or the next element or next leaf, whatever you want to call it. And you look at 3 and you can see that this is as index, the index over here is 1. So 1 is still less than 2, so this condition is not broken. And you can look at 3, which makes your reach extend to, well, basically extends to 1 plus 3, which is 4. So in essence, you have this limit, so you can just place this. So you have 1, 2, 3, 4, and then you sort of just move forward, and this condition will not break until you hit this guy. And over here, reach is also 4, you're at index 4. So this condition is still not satisfied, and it just breaks out of the loop, which means that you've essentially traversed through all the values. And that's basically it. So let's just go ahead and run this problem. Hopefully this should run. Um, and see this thing. Okay, cool. So let's just go ahead and submit this, and hopefully this should get accepted. And it did. So yeah, so that's basically it for today's video. If you didn't understand something, don't worry about it. Leave it in the comment section below, and I'll try to get back to you as soon as I can. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.